I looked at event processing latencies and basically how much you could do on one core. And by one core, I meant my laptop. And this was really early days. So yes, I did. That's why I said between 3 and 8 times faster, because it was what I observed was like 5, and there's high variance on that. The 5 is significant enough to know that, oh, Kafka Streams is the way to go, but it's not scientific enough to publish it as a scientific paper with peer-reviewed journals and all of that. I leave that for the professionals.
Hey everyone, and welcome to the SaaS developer community, where we talk of things of interest for SaaS developers. And with me today, I have an amazing member of the community, someone that if you're hanging out around our Slack, you have seen his questions, ideas, conversations, and insights. And you may have seen him announce his new open source project and also a company called Little Horse. So welcome to the show, Colt.
Thanks for having me, Gwen. It's an honor and a pleasure to be here.
Fantastic. So the most interesting thing that I learned about Little Horse was that you built it entirely on Kafka Streams. Why did you make the choice? Why Kafka Streams?
Why Kafka Streams? Basically, it all came down to performance. And how I discovered Kafka Streams is a little bit of an accident. That's a story for another time. But basically, the Little Horse is a microservice orchestration engine. You can think of that as a workflow engine that helps microservice developers build applications in business process management, event-driven applications, workflow management, and things like that, where there's distributed state and long-running processes. So think of it as a distributed workflow engine. And obviously, when microservices are involved, you need performance. Excuse me. I looked at various ways of implementing this. There's distributed databases such as Cassandra and Yugabyte, which is fantastic, by the way. And there's obviously single node databases like Postgres or MySQL. And all of them had their pluses and minuses. But what really came down to is if you want transactional consistency where you can guarantee certain delivery semantics, such as this task will never be scheduled twice without the client executing the task, knowing that it's a retry, never losing the state of your workflows, replicating it across 3 data centers. Really, Kafka provides all of that. And when you use Kafka Streams as your database, you get the benefit of the data stores co-located with the actual processing. So there's no network hop between looking up the workflow template, looking up the current state of the workflow, the tasks that are being executed. Everything is there right there on disk. And that allows you to have really, really high throughput. So it's depending on how you benchmark it and such. Use the architecture with Little Horse on top of Kafka Streams was about 3 to 7 or 8x faster than if I were to build it with something like Cassandra.
That's amazing. It really is. Did you try building it twice, like with Cassandra and then with Kafka Streams, and check the difference?
I didn't build like a full featured one. I did things where you process an event. I looked at event processing latencies and basically how much you could do on one core. And by one core, I meant my laptop. And this was really early days. So yes, I did. That's why I said between 3 and 8 times faster, because it was what I observed was like 5, and there's high variance on that. The 5 is significant enough to know that, oh, Kafka Streams is the way to go, but it's not scientific enough to publish it as a scientific paper with peer-reviewed journals and all of that. I leave that for the professionals.
You leave that to someone who is not trying to build a new orchestration product quite at that time.
I was convinced that Kafka Streams was the way to go for performance reasons, and it's turned out quite good. And as long as I convince myself, then the benchmark numbers that we've gotten, like for example, on I think it was 6 nodes or 6 pods running in Kubernetes, we're able to schedule 18,000 tasks per second. So that's a lot of requests, and especially given that it's transactional, consistent replication across 3 availability zones. So if we lose the leader, all the followers are in sync. Given that constraint, that's still pretty fast, and that's hard to do with another backing data store.
Yeah, I completely agree with that. And the way you describe the speed benefits, it almost sounds like it basically serves as a built-in cache. right? You said, hey, I have all the data right here in the same process, right here in memory. I don't need to do any network hops to get my data. It's basically an always consistent cache in the memory of the service that you're running.
Exactly, that's correct. And the tricky part is, if it's a distributed system, you need to partition correctly so that all the data for one workflow is on the node. And if you're a Kafka Streams user, okay, well, why don't you just make the key for every message the workflow run ID? So that's sort of how we got around it. And then we had to get kind of fancy with interactive queries in order to be able to do things like look for workflows that have failed within the last 5 minutes, or look for the workflow that has email equals foo@bar.com, for example. We have different types of indexes for both of those lookups and such. And that was the downside to Kafka Streams, because it's not a database. You have to add all of that functionality on top of it. But in terms of fault tolerance, reliability, and scalability, we got all of that out of the box.
Yeah, that's amazing. So you mentioned fault tolerance, and this is a really important part, because one of the downsides of this kind of architectures and caching in general, actually, is that if something restarts, you have to rebuild the cache and get everything right into a synchronized state. So can you talk about a bit about how you're handling this?
I think you're leading the conversation towards state restoration in Kafka Streams.
A bit.
So I am, full disclaimer for the audience, I am far less qualified to talk about this than Gwen, because she wrote a lot of the code that does this and was one of the first users of Kafka Streams. So please correct me if I get something wrong. But essentially in Kafka Streams, there is a state store, which is either RocksDB or some other implementation via in memory or something like that, where when you process an input message, you can write some state to the store, whether that's an aggregate or, in our case, the state of a workflow run, and then produce output messages and so on and so forth. Every time you write to the state store, in order to make that write fault tolerant, such that if the instance that did that write crashes, other instances can carry on the state, a message is sent to a Kafka topic. And that Kafka topic is called the changelog topic. It's compacted, which means, well, I'll get to that in a second. But basically, that changelog topic is a series of every single change that happened to that database. So if my processing instance crashes, and now I had like a couple thousand workflows on that instance, we don't want to lose that data. So the other instances will replay the changelog topic and reconstruct the state, right? Back to compacted before I continue. Compacted means that every message has a key and a value, and only the last message for a given key is kept in the topic, which is great if you write to the same workflow repeatedly, which we do a lot. And you have thousands of state updates. We only keep the latest state update in that workflow run, which is good for performance. There's some gotchas in terms of how the logs actually get rolled, and there's some configuration parameters to tune when the compaction happens on the Kafka broker side. But I think we don't have enough time for that today.
I don't think we would have enough time for that if it was the only topic for the next hour.
And I think I would love to have that podcast with you, because I would do none of the talking and all of the listening, and I would love to do that one day, but I think maybe not for today. But you can see the problem where, instance A is processing and it has thousands of workflows on it, and there's a lot of state there. It crashes. And now you're like, well, these workflows are mission critical data. I don't want to have to wait for 20 minutes or however long it is for instance B to replay the changelog topic to get that state hydrated again. So the answer, which I think I forget the KIP number for it, you might know, Gwen. There was a Kafka improvement proposal a while ago where we added standby tasks, where instance B would be listening to the changelog topic in real time and having a almost perfectly up-to-date copy of the data, so that when instance A fails, basically once the consumer session timeout expires, and then the consumer group coordinator realizes, oh, instance A is down, it will reassign the work to instance B, and instance B already has all of the state caught up. So then, we've observed that failover happens really, really quickly in Little Horse. So if you kill an instance, depending on how you have it configured, if you want to be really aggressive, we can probably get the failover time down to 10 seconds in terms of, oh, this workflow stopped advancing. Now it's advancing again on another instance, which is pretty fast. Another note about the fault tolerance and reliability. So technically in Kafka Streams, and not that I would recommend this, you could delete all of your instances and wipe away all of the disks that they have. And now we restart your application from scratch, and it will eventually resume processing exactly where it left off if you have exactly one semantics enabled. And you'll have no data inconsistencies at all, so long as your Kafka cluster remained intact and you didn't have data loss on your Kafka cluster, which is a pretty cool feature of Kafka Streams. And actually, if I have a little bit of time, I'll tell you a story about some tests we've done at Little Horse. So, reliability is important to us, and we care about not losing customer data and such. So I was like, well, what happens if I were to run Kafka Streams on a 3-node Kubernetes cluster and use proper rack awareness? So I spun up a kind cluster on my laptop, deployed a 3-node Kafka cluster, 3-node Zookeeper, this was a while ago, and a Little Horse in 3 nodes, and started running a bunch of workflows. And then everything was great. And then I said, all right, I'm going to Docker kill one of the nodes in my cluster. So that killed Zookeeper, Kafka, and a Little Horse instance. And then chaos ensued for about 25 seconds as they were figuring out what was going on. And then I noticed all of the workflows that were on that killed instance got translated over to the other ones, and continued, and there was just like a 25-second pause in activity, but there's no data loss. And that's a testament really to the reliability of Kafka and Kafka Streams. I think that's a hats off to the team at Confluent there.
You just nerd sniped me when you mentioned that you're running the Kafka Streams instance on the same node as the Kafka instance. Sorry, yeah, the Little Horse Kafka Streams instance with the same nodes as Kafka. Because now I'm thinking, if you get the leader allocation correct, you could actually have each Little Horse consume locally, which cuts down your network time even more. Is that how you kind of recommend your users to deploy it? Like, it seems, I haven't tried, but it seems pretty cool.
Well, I think what's more important is replace node with data center. I think you obviously want to have different machines for Kafka versus your own Little Horse instances versus Zookeeper. They have different requirements. And for example, Kafka needs more disk bandwidth and more memory. Little Horse is more CPU intensive because there's a lot of deserialization and serialization, which is a Kafka Streams topic I'd love to talk about. But you bring up a great point, which is cross data center traffic is both slower and more expensive. So there was a KIP, I forget the number again, which allowed fetching from followers, where a consumer can fetch from the one of the in-sync replicas on the brokers. And that is great because it reduces network traffic. However, it induces a little bit more latency because now you have to have the broker needs to acknowledge the request, send it to the follower. The follower sends an ACK back, and then another thing. So there's one extra network hop between when the message is available for when you're fetching from the leader versus the follower. But it does save a lot of money in terms of network costs. Now, this is an interesting thing I've thought about with Kafka Streams, right? In the most simple Kafka Streams use case, you have one input topic, then you have a changelog topic, and then you have one output topic. Like, that's a pretty hello world use case. Each of those topics, if you have a 3 data center setup, generally you'll have replication factor of 3, in-sync replicas of 2, if typical Kafka hygiene. Typical Kafka hygiene. So the interesting thing there is that there's no guarantees about whether all 3 of those partitions, the input, changelog, and output, are going to have their leaders in the same data center. And also no guarantees if the active task for that the instance with that active task is going to be in any data center. But it would be great if you could have the input, the leader for the input partition, the leader for the changelog partition, and the leader for the output partition all be on the same data center. There's no real good way to do that. There's a KIP, I think it's 925 or 926 right now, to optimize the placement of your streams tasks such to minimize the cost of network hops. That's someone on, I think it's Hao Lee working on Matthias's team at Confluent. By the way, fantastic team. The amount of strides that have been made in Kafka Streams over the last 4 years, absolutely incredible. Would not be possible to build Little Horse 4 years ago. Now it's totally possible. Hats off to them. They're fantastic. And Matthias, I happened to have the pleasure meeting him once. He's a really, really great guy. Anyways, I got distracted. So there's a KIP right now, a Kafka improvement proposal to optimize the placement of the streams tasks such that you minimize the network hops. That's like, that'll get you like, unscientifically 80% of the way there. What we're doing at Little Horse is we have a Little Horse platform, which is a Kubernetes operator subscription. And one of the features that we're working on right now, or rather an engineer who's much smarter than me is working on right now, is setting the preferred leaders of the partitions according to the streams assignment. So the operator, the Kubernetes operator, will look at the Little Horse cluster it's managing, read where all of the streams assignments are. And then because we have three-way replication across 3 data centers, every single data center already has a replica. And unless something's wrong with the Kafka cluster, it most likely will be already in sync. So all we need to do is set the preferred leader to one of the brokers inside that data center for the task for the input, output, and changelog partitions.
So
go ahead.
Wait, you mentioned the Kubernetes operator for Little Horse, which
yes.
is that, and that's part of your open source repository.
No, the operator is not open source. We call it Little Horse platform. It's equivalent to Kafka and then Confluent for Kubernetes. So you have to pay for CFK. Little Horse platform is another paid thing. So that was a shameless plug. I apologize.
That's all fine. If people are interested, it'll be fantastic. So is there any other Kubernetes operator for Kafka Streams out there that you're aware of, whether open, proprietary, like, is that a thing?
That's a really interesting topic. And that gets into the philosophy of why Kafka Streams. If you read some of the really old blog posts or listen to some of your earlier podcasts, why was Kafka Streams invented? And the answer is no, there are no Kafka Streams operators, because I say this with as much respect and love as possible. Kafka Streams is just a library. And that is, I mean, if Matthias is listening, I apologize for saying that, because some people hear that and say, oh, Kafka Streams isn't that powerful. I object strongly to that statement. But the fact that it is just a library means that you can embed it into any application that does basically anything, as opposed to Flink, where there's a cluster of workers that you deploy jobs to. You could have a gRPC server and embed Kafka Streams in it and serve interactive queries. You could have a Spring Boot app, a Quarkus application, just a plain Java-len application. You could have something that's headless, deployed on Kubernetes, deployed on premise, or running on a laptop or anything, and you can have Kafka Streams in there, which gives it really a lot of deployment flexibility. And because of that, Kafka Streams isn't quite on its own. It's not an application. So typically a Kubernetes operator is built to run an application, but Streams itself isn't an application. Streams helps build an application.
Yeah, I completely agree with that. And that makes sense. I think the thing I'm stuck on is that I can imagine a lot of things that would be common to every application on Kafka Streams, like in how you restart. Like I remember, delaying things. So if you, I think if you stop and start too soon, you at least back in the day, you needed to give Kafka Streams a bit of time to synchronize, and Kubernetes sometimes messed stuff up. So you needed to introduce a bit of slowdown on rolling restarts. There were some stuff around that. So yeah, I was thinking that there could be maybe not like an operator just ready to use, but like something other people can build on that would be generally useful for a lot of applications.
Yeah, I think generally people who are just starting out with Kubernetes tend to trip over themselves when it comes to stateful sets and anything that involves persistent volumes. And I've heard generally, if you walk to some tech conference, right, there'll be salespeople talking, and they'll be saying, "Oh, you should never run stateful applications on Kubernetes," and that's generally was probably true in 2017, 2018, but it's gotten a lot better. You still need to know what you're doing. So I think, yeah, there probably could be some framework for that. Also, I would never propose this KIP because it's way too chaotic in my own mind, but it would be cool if there was like a Kafka command line utility, which would be Kafka optimize streams leader assignments.sh, which would do that thing where it would set the preferred leader to the broker that is in the same availability zone as the Streams app, which owns it. But there's all sorts of problems with that. For example, there could be different consumers of those topics, different, the topology of the rack topology of the brokers might be different from the rack topology of the consumers. So it's way too messy to make an actual KIP. But that would be really, really cool.
Yeah. And something that I've said to many, many people who try to contribute controversial things to the Kafka community and fail. The Kafka community is fairly conservative because so many very large companies rely on Kafka. But if you have a good idea, absolutely nothing prevents you from putting it on GitHub. And people will find it and people will use it. There's so many examples of tools that were never adopted into official Apache Kafka and became massively, massively popular. I can think of command lines like Kafka Cat, maybe a good Kafkat, I think today, maybe a good example. Sorry?
Cruise control, perhaps?
Cruise control is another good example. There is Kafkat, which is a very nice CLI for Kafka, which is its own project. There are like 5 different UIs. I think all of them are popular. So I think if not every good Kafka project has to be contributed into the Apache Kafka repo, in my mind.
And I like the idea of keeping the core open source repo clean and very simple and easy to use, because API creep means now that you have a public contract, now you're required to maintain it, and I think Kafka does I think that you told me this, but Kafka does such a good job of backwards compatibility that Confluent can easily upgrade brokers in the background and the customers never notice in their cloud service, which is something we aspire to do when we launched Little Horse Cloud service. Right now, there's no Little Horse Cloud. There will be at some point in the future, but that's a really, really good thing to aspire to.
Yeah, and it will help you get the trust of your customers, which is obviously very important.
Very important, yeah.
We talked a lot about the different features of Kafka Streams that you kind of rely on. Is there anything extra exciting coming up in Kafka Streams?
Oh, I'm glad you asked that. There's a couple ones, and the ones I want to get to are, KIP 892. Also, there's this open source project called SpeeDB, which has some pretty cool implications for any stream processing app, including Kafka Streams. And I think we talked about KIP 925, which is the rack-aware task assignment already, which is pretty cool. I'm excited for that one to come in. So what is KIP 892? This is, when I said that 4 years ago it would have been impossible to build Little Horse on top of Kafka Streams, that was because Little Horse requires exactly once processing, because obviously we can't be scheduling credit card payments twice.
That would be a bit inconvenient.
That would probably, you said having your customers trust you is important. That wouldn't be too good for the cause. So because of that, Little Horse is a user of Kafka Streams exactly once semantics. And 4 years ago, Kafka Streams EOS was very, very new. And there are all sorts of implications about that. For example, I was reading the original KIP 98 for how transactions work way back in the day. And every single Streams task had to have its own producer, which means its own thread, its own record buffer. And it was not very great for performance, also very hard to manage. And there are all sorts of issues where if you took too long to process, you'd fall out of the consumer group, have a rebalance, and then processing would get stuck. But anyways, one of the last things I think that is making it the last thing that prevents EOS from being almost exactly as performant as at least once semantics is crash recovery. And what do I mean by this? So in exactly once processing, there is a Kafka transaction across the commit to the consumer offset topic, which is how far have you read in the input topic, the change log, which is any updates you've made to the state, and then also any output messages. So all those are wrapped into a Kafka transaction. So they're all atomic writes. What is not necessarily wrapped in those transactions is the writes to the RocksDB at this point. There is no synchronization between the committing of RocksDB, like flushing it to disk, and also, or any committing, and the Kafka transaction. So what does that mean if there's a crash? It means that we could have gotten to offset, let's say 100 in the input topic and committed that. And then we've processed the next 5 records and written them to the RocksDB state, right? And then we haven't yet, we've written it to the changelog topic, but we haven't committed it. And then there's a crash, right? So RocksDB is at 105 and input topic is at 100. So that means we have violated exactly one semantics. So what does Kafka Streams do today? It wipes the state completely. And then you have to replay the changelog topic from the beginning.
Oh, right, because it may have aggregated, like you cannot just undo the last things. Oh, man.
Undo.
Yeah.
Exactly, yes. So basically that means that if you have 2 standby replicas and you have 3 crashes within like 20 minutes, then you're going to have a delay because you're out of standby replicas and everything is replaying the processing. So basically right now, until this KIP which solves this problem, I'll explain how, until that KIP which solves that problem is adopted, we're going to have 3 standby replicas, or 2 total standby replicas, 2 standby replicas, 3 total replicas in Little Horse. But once that KIP is done, basically we'll be fine with 2 because it's already replicated 3 ways on the Kafka brokers.
And we just saved a bunch of money.
Yes, exactly. So how does the KIP work? Well, basically the idea is, this is the second attempt at solving this problem. The first one involved having a separate RocksDB store where you write all the uncommitted writes to that RocksDB store. And then when you commit the Kafka transaction, you copy everything from that write-ahead store into the old store. That had severe performance implications, unfortunately. I think it was a 96% decrease in throughput, which isn't great. Then the current implementation is, the reason why they tried that is because of the one drawback of the current implementation, which is a gentleman at Meltwater is creating a RocksDB transaction using the write batch with index function. I believe that's what it's called. I might have got that wrong. I'm not a RocksDB expert.
I'm thinking Minizer. I never even heard of that.
Yeah. So basically, you could think of it as a database transaction. So when you open the Kafka transaction, you open a RocksDB transaction, and then you commit the Kafka transaction, and then you also commit the RocksDB transaction, but also commit along with it the current offset of the input topic that you just committed to Kafka.
Nice. So it's basically a 2-phase commit between Kafka and RocksDB, driven by Kafka, with Kafka as the driver, because that's where the state of the 2-phase commit is kept.
Exactly. And then
Nice.
you know what the current offset is also stored in. Well, actually, they've gone back and forth between whether it's on a file or the store itself, but the current offset you can read and determine, maybe you replay 20 messages instead of all 2 million messages. So I'm very excited about that. And the reason why they first tried the other implementation with the separate store is because now, we have a bunch of stuff in memory, right? And then it becomes tricky to bound the side. You might have to commit early because you might overflow a certain config for memory, right? That brings me to the other super cool improvement I wanted to talk about, which is there is this new project called SpeeDB, which is a fork of RocksDB. And they have been working very closely with several members of the Kafka Streams community. Not me, I'm just a user, not a contributor. But they've been doing some really, really cool ideas. So for example, SpeeDB has, they're thinking about adding an ability to bound the in-memory transaction buffer, and if it spills over, write it to disk and still maintain the transactional semantics, which would kind of remove the problem of, now we have to commit early in KIP 892 if the transaction goes beyond the amount of memory that we've configured, right? And that would be really, really cool, because then that KIP would have absolutely no impact on performance at all. In fact, writing with batch is more performant in RocksDB than not writing with batch. And I think their SpeeDB open source is a little bit less prone to write stalls, where in Kafka Streams, if you grow beyond a certain amount of state in your RocksDB instance, I think I noticed at 30 gigabytes, performance of RocksDB goes down 37% in terms of
30 gigabytes is In memory, you mean? No.
No, on
No.
disk, right?
Yeah.
Yeah. So if the RocksDB instance, which is one streams task state store, has 30 gigabytes on disk in it, the performance decreases significantly. So my benchmark, one that I ran, it also depends greatly on your use case, but for me, 37% slower in terms of processing messages through the Kafka Streams app once I got to 30 gigabytes of state. And a lot of that was due to write stalls. SpeeDB open source, I played around with it a little bit. If you configure it properly, also, here's a quick plug. I suggest level compaction over universal compaction, much less likely to have write stalls. The SpeeDB open source does a lot better than, I'd say it was about 15% better than RocksDB. But the real kicker is they have an enterprise version, which is paid. When we do state restoration, we talked about that a little bit in the past, which is you have to replay the changelog to rehydrate your state. I was playing around and with that benchmark repository I was playing with, SpeeDB open source, when you configure it the same way as RocksDB and you tune them both to be optimized for this use case, SpeeDB open source was about 15% faster than RocksDB, but SpeeDB Enterprise was 2.5 times faster. So basically it took 2 minutes to restore the state, and it was 5 minutes for RocksDB to restore the state. And that has significant implications. So for example, if you are trying to add a new processor, right? You need to create a new pod in Kubernetes in your stateful set. That thing needs to rehydrate all the state, right? So now instead of having to wait 5 minutes for it to be able to start processing, you can start processing again in 2 minutes. So
yeah, and I think a lot of people, like, it sounds like 2 minutes, 5 minutes, who cares? But remember that even for, I think, 99.95% SLA, which is not crazy high, I think this is bare minimum for cloud these days, you only have 40 minutes of unavailability for an entire month. This is all you have, even no matter what kind of maintenance you need, etc. So halving it basically means you can maybe deploy twice as often, for example. This is a huge deal for a software company.
And ideally, if you manage your standby replicas properly, you're never going to have to wait on restoration in order for availability. And that's one of the things that we do at Little Horse is we never want there to be 0 up-to-date active tasks. So ideally, you wouldn't have to worry about that for availability. But the real gain is in elasticity, which is, oh, there's a spike in demand. You know, everyone's talking about how they want to only use as many servers as they need, but then, you know, there's about to be a big ad on TV, and then everyone's going to be going to their website. So you need to increase, right? Now you can probably meet that new demand if you know 5 minutes in advance instead of 2 hours in advance. It's sort of like how tiered storage and Kafka increases elasticity.
Exactly. And I remember when, I think it was AWS DynamoDB, they have the DynamoDB serverless, and when it's first shipped serverless, it took it like 20 minutes to scale out. Which is like, if you have latency spike, 20 minutes is like forever. So like nobody was, it looked like a nice proof of concept, but come on. And as they cut it down to, 10 minutes, 5 minutes, I think now it's barely noticeable. It was obviously a huge quality of life improvement. So I can totally see that being more responsive to spikes is a game changer for something like Little Horse.
Exactly. And I think we're working on figuring out a way that we can have like a Little Horse Plus version, which has SpeeDB Enterprise in it. The default for the default is going to be, we're not going to be using RocksDB. We'll be using SpeeDB open source just because it's a strict improvement over RocksDB. And another cool thing is it's 100% binary compatible. So all you have to do is take out the RocksDB JNI from your jar and then drop in the SpeeDB JNI and rename it to lib RocksDB JNI, whatever the name is, and it will work perfectly out of the box. And you just get a performance increase for free.
Is there any downside?
Not really. It's just that getting as you said, Kafka is a conservative project, so getting them to adopt something new is a bit of a, let's just say a bit of a process. So I think the team is working on putting together some formal benchmarks, and if I think what they're worried about is it's Apache. The open source version is Apache licensed, but it's not an Apache project. I don't know if RocksDB is or not. But I think that they're like, well, is there a huge community behind it? If there's a huge community behind it, I think they're going to at least,
Mm.
I think the first step would be have an opt-in SpeeDB versus RocksDB config. And, I would obviously, we're going to be compiling Little Horse with SpeeDB instead of RocksDB anyways. So that would just make our build pipelines a little bit simpler if they did that.
My guess is that if they would open the optionality, there would be a lot more people like, oh, we also have an option. Try our levels DB, try our silo DB. Like there's so many other things you can try Kafka Streams with.
Yeah, well, the only thing is there's no code changes at all.
That's right. Yeah,
SpeeDB,
it's not
right?
even an API. It's just
It's
RocksDB is the API. So yeah.
Yes, RocksDB is their API, and the only thing that has to change is the compile flag. So it's basically to officially change it, it's a 2-line PR. And
and let me guess, also 200 message conversation.
Yeah, a 2-line PR with 200 messages in the mailing list, and basically all you have to do is change the build.gradle file, and then it would be right, and then it would be using SpeeDB open source. So I would vote yes for that, Kip. I'm strongly in favor of it, but I'm not the dictator of Kafka Streams.
You also mentioned keep 925.
Yes. That was what we talked about earlier, which was the rack-aware assignment for the streams partitions. So where the streams group coordinator or group leader rather would choose would assign streams tasks such that it minimizes the amount of cross data center traffic, as opposed to what we're doing with the Little Horse operator, which moves around the preferred leaders to minimize the traffic. So it's just like it's an alternative that is a lot easier to do. Yeah, we already talked about that one.
Yeah, makes sense.
That's one of the things I'm excited about.
Yeah, for sure. So it sounds like the community is doing all the right things and you're excited about stuff going on. But if you were the leader of the community, if you could dictate your own roadmap, if you were Matthias's manager, if you were to hire Matthias tomorrow, what would the roadmap look like?
Well, I think if I were to hire Matthias tomorrow, I'd just say keep doing your thing. But I actually might make him work on some Little Horse internals because there's a lot of code that we do right there.
So that's the correct answer for sure.
But if I were to be the leader of the Kafka Streams community, there's a couple things that I don't know the answer to. So obviously I would push KIP 892 and then the SpeeDB thing. Those two things are going to be huge for every user of Kafka Streams. Once KIP 892 is adopted, I would vote for making exactly one semantics the default, because I don't really see the, if you run it properly, right, the biggest bottleneck in a Kafka Streams application is actually serializing and deserializing the data. The input messages and the output messages, and also what goes in and out of the state store. That is by far the biggest bottleneck in terms of throughput. It's not the committing of the transactions in Kafka. So exactly one semantics, once you get the crash management back up with 892, I would vote to make that the default. But some things where I don't know the answer to how to do it, right? Let's just say that you're running a Kafka Streams application in an on-premise environment, and you have your Kafka cluster on-premise, right? And it's an exactly once processing application. You don't have tiered storage enabled, so you don't have the forever history of your input topic. And now we have a company-wide, we're migrating to the cloud. And as part of the cloud migration, you're going from an on-premise Kafka cluster to Confluent Cloud cluster, right? How do you get your Streams app from point A to point B, where point B is running on, let's say, EKS and talking to the Confluent Cloud cluster, right? I have there's a lot of ways to do it, right? Ideally, if you have the full history of the input topic, you just replicate the input topic and start it up again on the new cluster, and then it hydrates itself, and now you have the app on the new cluster. But that's not always the case, right? It would be cool if you could replicate the changelog topics in some way, and then have a utility that would hydrate the state stores in a passive manner, and then you could switch over the producers. I don't know, like with exactly once, there's all sorts of gotchas, and I don't know how it would work. But if I were in charge of the community, I'd put someone really smart like Matthias on that. So,
Yeah, no, I'm thinking like if you could as you said, replicate the change logs, and then if you could put standby tasks on a different running from a different cluster,
yeah,
and then you could use the failover mechanism to those for those standby tasks.
yeah, and also like, what if you have if you're not migrating the Confluent the Kafka cluster, but rather you want to migrate your Streams app from on premise to a Kubernetes environment, and it's still pointed to the same Kafka cluster. Even that itself is still kind of tricky.
Really, wouldn't it be easy to just because it's still the same Kafka cluster, so you just start putting standby tasks on the other.
Yeah. But the thing is, there's no way to tell Streams, I want this standby task right there, right? So you just kind of have to hope that you have to use rack awareness tags, and that hope that it eventually figures it out. You can't imperatively say, I want a standby task right there.
Wait, does that mean that you have no like rebalancing mechanisms because you cannot specifically locate tasks where you need them? I'm talking about load balancing, not necessarily like rebalancing. Like rebalancing means so many things in Kafka, but
so there's a couple configs. So when you're reassigning work, you can't control where the work gets assigned. There's a Streams partition assigner, I think is the name of the class. You can't override that. That is the consumer group assigner, and it has its own logic. It's very good at what it does, by the way. And it's very good at ensuring that you only assign tasks to where the state is already warmed up. Yeah. It's also good at rack awareness and such like that. So you could trick that into doing a migration by adding stuff with different rack IDs, but then it's really, really hard to monitor when they're all caught up. So when it's safe to kill the old cluster, it's hard to monitor. It's not really surfaced to you, and you can't tell it, explicitly to move replicas immediately. There's a config called num warmup replicas, which is how many, when I add new instances, how many Streams tasks can be hydrating from the Kafka cluster at once. And the reason that's there is to do throttling, so you don't saturate your network by adding 10 nodes, and now all of them are trying to hydrate 10 tasks. So you have 100 tasks. Yeah. So like it is possible to do it, and we have a run book that we haven't actually tested yet for how to do that with Little Horse. We're going to test that soon, but it's not very easy, especially given the monitoring aspect, where, for example, you don't know that it's very hard to tell when each of the instances are caught up, and it's safe to turn off the old cluster, right?
Yeah, no, and if you honestly, this seems like monitoring 101. So this is one thing I hope goes on the community roadmap fairly soon. How can you operate anything in production without knowing if you're caught up?
You can do it. There's just no CLI to do it. You have to write like an endpoint that will talk to the Kafka Streams object and then look at the consumer group, and then you can see the lag of all the instances. But it's not really such that you can say, oh, here's a list of every single Streams task. Here's where they're assigned, and here's how caught up it is. The standby replicas are on these nodes, and so on and so forth. There's no command line utility to give you that picture. You kind of have to infer it from the consumer groups. All the data is there. It's just not really presented in the most easy manner.
Yeah, I know that a few years back, someone added the first probably HTTP endpoint to Kafka Streams for the being able to query the data store directly. So maybe it's time for the second one for monitoring.
We have that Little Horse, actually, the open source version itself has an internal gRPC endpoint, which gives you what I was just talking about, where it shows you every single Little Horse server plus all of the tasks that are on it, how caught up they are and such. And basically, we just make a bunch of calls to the admin API to inspect the consumer group and put that together. And then we can display that on like a Prometheus dashboard or something.
So it seems like everyone needs one. Now that I think about it, it's not a Kafka Streams application, but Kafka Connect had to do the same thing, add an endpoint that allows you to actually inspect the current state. And yes, there is, of course, a state topic and all that. It's just a convenience thing that kind of everyone needs.
Yeah, that's pretty cool. So if time permits, I do have a question for you,
Okay.
because you've seen a lot more Kafka than I have. What if hypothetically someone wanted to do an active Kafka Streams deployment? Is that possible? And how would you do it? I don't think it's possible right now, but how would you make that possible?
So I have to say, I spent very little time on Kafka Streams, so I absolutely cannot talk about it in authority. I spent a lot of time thinking about active Kafka. And I think, and again, like it's things that I thought about a bunch of years back, but I think the way I thought about it was to use the replication mechanism. So back then, I think the status of the art was either Mirror Maker or Confluent Replicator. I think now there is all the cluster linking stuff. And basically have bidirectional replication and to use partitions for that. So every topic will have US East 1 partitions and US West 2 partitions. And then you need to have smart assigners exactly to know, okay, I am the application running in US East 1. I am supposed to be reading from those. How do I know where do I need to start reading from both of them? So you need a lot of application level logic, which is exactly why I hate it when people say just a library, because libraries do a lot. Let's call it SDK, because I think people think that SDKs are fancier than a library. But yeah, you need a smart SDK that will maintain states, that will know, even if you have something like console, for example, console is very good at keeping heartbeats and health checks for a bunch of clusters. It will be like a third location. And then the clients can check with console, hey, who is up? Where am I supposed to be reading from? You can have things like Linux AJ proxy. So you will not be reading directly from Kafka. You would actually be reading from a router that will make sure your requests go to the part that is available. And remember that each partition is essentially its own connection, which is a huge pain in the ass. But in this case, it's actually a very big benefit, because if each partition is its own connection, it means that the proxy can route the connections appropriately. So, and these are all kind of design patterns that are very much not unique to Kafka. I've been dealing with active databases, or at least the holy grail of active databases, since I was not accepted to work for Amazon back in 2008. They rejected me specifically because I did not know enough about high availability.
Oh my goodness.
And I was so hurt by the rejection that I found a new job, and the new job was a consultant. And my first client, we worked on high availability, because I insisted we're giving you the world's best high availability system, because I was just so hurt by Amazon telling me I'm not good enough.
I find that hard to believe, given I don't have it. Actually, I have it right there, right next to my bed, my favorite textbook, the Kafka Definitive Guide. I think if anyone is starting out with Kafka, you need to read that first, and then basically you'll know everything you need to know about Kafka.
Yeah, it's very long read, so start working with Kafka before you read it, and kind of multiplex.
What you do is basically you replace Instagram doom scrolling with reading the textbook, and you'll be done in like 2 or 3 weeks. And it's actually a really engaging read. So I just decided, okay, I'm not going to use my phone for the first hour or last hour of the day, and then I got through the book in 2 or 3 weeks.
That is a very good tip. What are you reading now? So we'll all know what is the cool technology of the future.
Well, it's actually not really of the future. It's the nonfiction I'm reading right now is Terraform Up and Running. So basically, the idea is right now, Little Horse, we have the open source project, which you can run however you want. We have Little Horse platform, where we're building a Kubernetes operator that's almost ready to ship, which will run it as a Kubernetes project in your own cluster. The next step is Little Horse Cloud, where we have a bunch of cloud infrastructure and we run Little Horse as a cloud service, right? And there's engineers on my team who know Terraform much better than me and are much better at monitoring and high availability and security than me, but I want to catch up. So I'm learning Terraform right now.
Amazing. By the way, I'll give my own plug. Back when I was considering starting on Terraform, I talked to a friend she was also a founder, but before that, she was the head of infrastructure at Lyft or something serious like that.
Mhm.
And she said, our life has been way better when we migrated into Pulumi. Okay,
Interesting.
let me try out Pulumi. And you know what? Never looked back.
Interesting. So I'm reading the wrong book.
I did not read any Pulumi book. It is basically just a library so everyone can make fun of things being just a library. But you know what? It means that it's not this big command line of Terraform. So I kind of like it. And you use it. They have library in like a bunch of languages. I think they have Python. I use it with TypeScript. And I'll not say it's been problem-free because it is a reconciliation model, which is always hard to wrap your head around reconciliation loops, but it's really nice. So
is it open source?
I believe it is. I have read the sources. I haven't checked the exact license because I had no intention of modifying anything.
I see. Yeah, well, I'm a big fan of reconciliation loops because that's ironic as someone who's building an imperative workflow engine, but I love Kubernetes operators and they're all reconciliation loops. So I think Terraform it's declarative. I don't know how it works in the back end, but it's declarative. The DSL is interesting.
That was exactly my thought. It's trying to do a lot in a DSL that was designed to be very simple, so it's always a hard one.
There's 4 different ways they do for loops. That's the chapter I'm on right now, and each of them addresses massive shortcomings of the one that came before. And at this point, you might as well just why not write? I think the operator pattern would be so much better if you could have an operator for infrastructure, right? Why can't someone build an AWS operator that you can use to create a VPC, create a bunch of subnets, create a bunch of IAM roles, and then deploy an EKS cluster into it?
Interesting.
Instead of being a Kubernetes operator, you give it a YAML, give it a sort of a YAML file, right? But I think that's that's what Terraform intends to be, except I don't know. I'm not an expert on this subject matter.
Yeah.
So
Yes, neither am I. But that leads me maybe last question, since we are both kind of starting something cool from scratch.
Yeah.
Advice for other people who are starting something cool from scratch.
Oh my goodness. Find smart people and ask them questions. And use open source Slack communities as much as you can. So if you're using Confluent, talk to Confluent. By the way, I met our lead engineer on the Kafka Slack jobs channel, and he's absolutely fantastic. Great person, really smart, really kind, great engineer. So just ask for help. People will be willing to give it to you. And also, coffee is not a replacement for sleep. I learned that. I learned that the hard way. I don't write good code when I'm tired.
So true. And the number of mistakes that I did at around 2 a.m. when I thought I'm almost done and then regretted it for the next 24 hours of my life has been quite high. So
yes,
both of those are good advice. Use the community and get some sleep.
And let me know when Nile is out. I know it's in stealth mode. I'm very excited to see what it does, and maybe give it a spin.
We will let you know. Absolutely.
Okay. The suspense is real.
Yes. Thank you so much for joining this conversation.
Yeah. Thanks so much, Gwen.